Now we look at the second form of the limit involving radical function. In the second form, you can see that the radical, only the one radical can be on the numerator, or the radical can be in the denominator. So the difference, so here you have to pay attention is, one is approach positive infinity, another one is approach negative infinity. So you have to be careful. One is positive infinity, one is negative infinity. So the radical can be on the numerator or on the denominator. Next, you have to remember that for this part, x actually also equals to square root of x squared. Same as x squared equals to square root of x power 4, and x cubed is equals to square root of x power of 6. So normally what we're going to use is x is equal to square root of x squared. So you have to remember this part. Next, let's look at the example. So in this example, x approaches positive infinity. So in this case, first example, we will look at when x approach positive infinity. So as we learned before, if x approach positive infinity, we will divide the denominator and the numerator with the highest degree of x in denominator. So if x approach positive or negative infinity, we will divide the denominator and the numerator with the highest degree of x in denominator. So in our denominator, the highest degree is square root of, you have to take into account for the square root of x squared. And on the same time, you have to remember that square root of x squared also equals to x. So you have to remember here. So next, so limit when x approach infinity, I will divide the denominator and the numerator with square root of x squared. So here will become 1 over 2x divided by square root of x squared. Same as the denominator, square root of x squared plus 3 divided by square root of x squared. So for the numerator, for this part, here we have to change to x because this one is not involving radical. So here we can change to x. Next, limit when x approach infinity. So what we have here is 1 over x. We separate 1 by 1. 1 over x minus 2x over x. Whereas for the denominator, square root, we can combine the square root with the square root in the denominator. So we will have one big square root of. So here will become x squared divided by x squared plus 3 over x squared. Next, I try to simplify. Limit when x approach infinity, here 1 over x minus 2 over square root of x squared divided by x squared is 1 plus 3 over x squared. So next we will substitute the infinity. As we all learned before, any value divided by infinity will become 0. Same as this one. 3 over infinity squared is 0. So we have here is negative 2 over square root of 1. So negative 2 square root of 1 is 1. So the answer is negative 2. So here is the answer for example 1 for the second form. So in the second form, the radical is either on either on the denominator or numerator. So here we will divide by the highest degree of x in the denominator, which is square root of x squared, and on the same time you have to remember that square root of x squared also equals to x. So here we have to change to x, and then we simplify and substitute the value.